Dr. Kim, and thank you, Dr. Yamaguchi. Good afternoon, gentlemen and ladies. First, I would like to thank you, the people of Taiwan and people from other countries, for extending extraordinary help during our national disaster. Thank you. My name is Isao Kato, and I work for a Japanese electric utility called Tohoku. This is a great honor for Tohoku and myself to be invited to this conference. I'm not here for what I did, but I'm here what my colleagues did for Tohoku or the Tohoku region itself. Professor Todrius kindly asked me to talk about what happened at Onagawa Nuclear Power Station on that day, March 11th. Onagawa is the closest power station to the epicenter, as indicated there, of that earthquake and tsunami. You have read and heard enough about Fukushima that I'm going to talk about the other story. There's a story. Okay. First, let me talk about who we are. This map shows the entire geography of Japan, and the Tohoku Electric Power Company is one of 10 electric power companies, utilities in Japan. As shown in red here, we serve northern part of main island of Honshu. Land-wise, we cover 20% of Japan, and population is about 10% of Japan, which is 12 million people live in that red shaded area. The word Tohoku means northeast, so our corporate name is something like Northeast Electric Power Company. Our installed capacity is, or I should say was, 19 gigawatt, and we have hydro, oil, coal, gas, solar, wind, and geothermal power stations. And we also own and operate 2 nuclear power stations. One in Onagawa, we have 3 boiling water reactors. Another site is called Higashidori. We have 1 boiling water reactor out there. For Tohoku, before the earthquake, as shown here, 28% of power was generated from nuclear. But now it is 0. As you are well aware that only 2 reactors are operating at this moment out of 50, or you can say 54 licensed reactors. If you minus 4, that is Fukushima 1 to 4, then it's 50. In this slide, let me also point out that the Tokyo Electric Power Company, shown as light blue, serves the Tokyo area. 3 of its Tokyo's large nuclear power stations, including Fukushima Daiichi and Daiji and Kashiwazaki Corridor, are located in our area, in our service area, sending power to the Tokyo metropolitan area before the accident. On that terrible day, March 11th, 18 months ago, we lost 35% of our installed capacity, mostly by tsunami. 5 million customers were left without power for several days, but within 3 days, we restored power to 80% of our customers with the help of other utilities. This slide shows you that we have power stations on both sides of the main island. These pictures show the damage caused by the tsunami at several of our conventional power plants. This one is Fukushima, which is Haranomaki Thermal Power Station. It's coal-fired power plant. That plant was attacked by a 50-meter tsunami, and the distraction was completed. It will take another year before we can get it online. So they're working 24 hours right now. Okay, on March 11th, 2011, about 18 months ago, the strongest recorded earthquake hit the Tohoku area at 2:46 p.m. Friday. It's a Friday. It lasted for 3 long minutes. 3 minutes is a long earthquake even for Japanese. let me remind you that it was not only one huge earthquake, that it was followed by many, many stronger aftershocks. And that aftershocks continue even now. 40 minutes later, or 40 minutes later, a series of huge tsunami attacked the Pacific coast of Japan. The epicenter was about 130 kilometers out in the Pacific Ocean from Onagawa nuclear power station. The magnitude of the earthquake was 9.0 on Richter scale, which was the largest earthquake ever recorded in Japan. 16,000 people are dead, 3,000 are still missing. I confirmed it because you had a question. If they are still missing, they are still missing. And 130,000 houses were completely destroyed. And 340,000 people are still relocated in various areas of Japan. In the town of Onagawa, the population before the earthquake or tsunami was 10,000 here. After, because of the tsunami, they lost about 10% of its population. Here are the photo of the downtown area before the tsunami and thereafter. The right-hand side photo was taken by Asahi newspaper. You can see the devastating damage throughout the area where many years ago I lived with my family. So this is the same building, and the whole houses were destroyed by the force of the tsunami. Okay. This is the aerial view of Onagawa nuclear power station. The photo was taken before the earthquake and tsunami. So this is how the station was and how the station is at this moment. The power station is located about 20 minutes southeast of Onagawa town. We have 3 units. Unit 1 is over here, and Unit 2 over here, and Unit 3 over here, which is the latest unit. And those units were manufactured by Toshiba and Hitachi. The most important feature of this power station is a site grade of 15 meters or 50 feet. But yesterday, I learned that the site grade of Chinshan's nuclear power station is 20 meters. So you might have lost interest in my talk, but I will continue anyway. And let me also bring it to your attention that you don't see any pumps or motors or pipings in this harbor area. We have seawater circulation pumps in this area, girded by site grade, what we call seawater pumping. We have these important pumps up on a site grade, and we deck a special structured space called pump deck. So these 2 features are very unique. Well, actually, the second feature is very unique to Onagawa nuclear power station. And now we have new admin building, which is anti-seismic, which has anti-seismic feature. But the building was under construction at the time of the earthquake and tsunami. Right, so because of these features and the well-organized actions of my colleagues at the plant, the site grade remained dry, and all 3 units achieved cold-shutdown conditions. On that fateful day, Unit 1 and 3 were operating at 100% power. Unit 2 was finishing a reefing outage, and we restarted the unit at 2 p.m., which is just 40 minutes before the earthquake. Okay. This slide shows the timeline of events. At 2:46 p.m., all units slammed because of the acceleration detected by the reactor protection system. About 10 minutes after the earthquake, at 2:57, there was a fire alarm in Unit 1. And but Unit 1 reached cold shutdown condition by midnight, as showing green on your right-hand side. Unit 2 was brought down to cold shutdown condition within 3 minutes by 2:49 because we just started the reactor. Then at 3:29, about 40 minutes later, after the earthquake, a serious tsunami hit the plant. And as a result, two emergency diesel generators, the tsunami, the tsunami induced an internal flooding, and as a result, two emergency diesel generators tripped. But we had off-site power available, and third diesel generator for Unit 2, so we had power. For Unit 3, there were no major damage to the safety related systems. We could bring it down to cold shutdown condition by 1 a.m. the next day. Okay, at the bottom, the timeline of events for Fukushima Daiichi Unit 1 is shown for your reference. Fukushima Daiichi scrambled when the earthquake hit, and it declared the emergency level 1 at 3:42 and went to level 2. And they had the hydrogen explosion the next day. And that explosion was detected at our plant later the next day. Okay, about 12 hours later, that radioactive material reached our site vendor. Let me talk about the status of site power at Onagawa Nuclear Power Station. Before the earthquake, we had 5 lines, 2 on Matsushima line, 1 on Tsukahama, and 2 on Oshika lines. And Matsushima line on your right-hand side and Oshika line on your left-hand side are interconnected within the site. Okay. We lost 4. That one line, which is the second line of Matsushima, remained available. And with regard to emergency diesel generators, we have 8 on site, but 2 diesel generators tripped on Unit 2, but 6 diesel generators remained available on site during the course of the event. For those who have read the article appeared in the May issue of NS Nuclear News, the summary of my presentation written by Professor Ford contains grave errors. So let me make it clear here again that we had 1 on-site power available and 6 emergency diesel generators also available on site throughout the event. The tsunami hit the station at a height of 13 meters against a 15-meter site grade. Therefore, as I told you a few minutes ago, the site grade remained dry. The tsunami toppled the fuel tank that you can see over here. This is the fuel oil tank for house boiler, so which is not a safety system, re-rated system. And tsunami also again induced the internal flooding of the reactor auxiliary building, which later resulted in the trip of 2 emergency diesel generators. And we later learned that there is a uniform subsidence of 1 meter or 3 feet throughout the Oshika Peninsula or surrounding area. So minus alpha means 1 meter. Now it's like 60 centimeters. It's coming back little by little. And we are closer to the United States by 5 meters because of the earthquake. So this is a summary of the major damage to the Onagawa Nuclear Power Station. There were 3 major damage to the plant. Unit 1 had a switchgear fire, which is non-safety switchgear, and fuel tank got well by the force of the tsunami. And we had a emergency diesel generator trip, 2 trips on Unit 2. So this is a cross-section of Unit 2. I'm going to talk about an internal, tsunami-induced internal flooding of Unit 2. This is a cross-section of the Unit 2. This is the reactor building of Unit 2, and this is the auxiliary building of Unit 2. And you have the ocean over here. Okay, this is the intake structure. And here we have the structure called what we call super recirculation pump head. Okay, this is the harbor level. This is normal ocean level. And this is 50-meter site grade. Okay, the tsunami hit the plant at 15 meters, and our site grade was 15 minus 1. Okay, so again, it did not flood the site from above. It penetrated into that concept. The strong undercurrent passed up through the level transmitters instrumentation tubes, and as shown here by the flooding path by our red dotted line, the seawater was pushed upward into the pump pit and flooded the building into the pipe trenches and then flowed into the reactor auxiliary building basement. In the basement, there are cooling systems for the emergency diesel generators. And diesel generators are located on the first floor here of the same building. But the diesel generators are dependent on the cooling system. So when the cooling system tripped, two diesel generators tripped out as well. Again, the tsunami did not flood the site from above, but it partially flooded the auxiliary building from inside. This slide shows the penetrations. Okay, this is a penetration where the tsunami shot out. And we had a better sealing for other penetrations, but this is something we added after the completion of plant construction. So we thought it would be a good idea to have these additional instrumentation, but these things happen. And now the instrumentation tubes are shut completely with reinforced lids. The bottom picture shows one of the cooling system heat exchangers, and this one was flooded up to 2.5 meters. Okay, now you may want to ask me why the site grade of Onagawa is 50 meters high. Let me talk about the history of tsunami evaluation for this power station. In 1970s, when we filed the Unit 1 license application, the recorded tsunami near this site was only 3 meters. Because the station is located in the southern end of an area affected by tsunami in the past, our civil engineers studied the tsunami history of this area. And through consultation with the professors of local universities, they decided that the site grade had to be at least 10 meters. 10 meters. So it's not 3 meters times 5. It's 10 meters plus alpha. So after the discussion among these experts, the site grade was set at 15 meters, and that decision saved Onagawa. And in 1987, when we filed the license application for the second unit, we knew more about its tsunami history, and we had a better numerical simulation technique for tsunami prediction. So the revised evaluation for this site was 9.1 meters. But the number was still well below the site grade. But what we did was that we reinforced the site grade with concrete up to 9.7 meters. I will show the picture later. Okay. And in 1994, when we filed the license application for Unit 3, the predicted tsunami height remained the same. And in 2002, we had a trial evaluation based on the new methodology, and the predicted tsunami height was 13.6 meters, which is very close to what we had last year. Right now, we are re-evaluating tsunami and earthquake predictions based on the records and observations that we gained last year. When we learned that updated tsunami prediction of 9 meters, we reinforced our site grade up to 9.7 meters with concrete. Okay, this picture was taken from the harbor side, and you are looking at the reactor building of Unit 2. Okay, so this is as high as the 50-meter site grade is. Okay. So here is a comparison between Onagawa and Fukushima Daiichi. Our predicted tsunami was 9.1 meters for Onagawa. That's high or 6 meters for Fukushima. Site grade was 15 meters for Onagawa and 10 meters for Fukushima Daiichi. As I said earlier, we had a seawater pump eroded inside a pump bed at 14.8 meters, and their pumps are located in 4 meters or with some barriers up to the height of 6 meters. The tsunami that we had was 13 meters. We had a record. We had a backup tidal gauge which measured the correct data into that huge tsunami. And 13 meters is estimated for tsunami because they lost the instrumentation. We had a one outside power available, and we had 6 diesel generators available. We also had a DC power as well. So just like anybody else, we continue to upgrade seawalls, watertight seals, or safety-related systems, such as emergency AC power systems and heat removal systems. I'll show you some of the examples. This is a picture of the newly installed 3 air-cooled diesel generators with a capacity of 5,000 kVA each up on a small hill at about 52 meters above sea level. Okay, our site grade is 15 meters, so we put these air-cooled diesel generators up on a 52 meters area. This is only a picture, but this mobile equipment known as hydrosurf has been extensively used in the firefighting area. We plan to use them as alternate seawater pumps when they are damaged by flooding or whatever threats you might have. We have 1 hydrosurf already at Higashidori Nuclear Power Station, and we will have 2 hydrosurfs at Onagawa later this month. Okay, and this is a picture of the additional 3-meter seawall on top of the existing site grade. This is the original site grade, and we added another 3 meters. So now, because of the subsidence, we now have the 17-meter seawall, and we also installed the check valves. You know, because when the tsunami might overflow into the site grade, you might have a pool. So we installed the check valves for that threat. And also we are continuing emergency drills with new equipment, even in severe weather conditions. Well, better, it's not just us, everybody else is doing the similar thing. Okay. During the earthquakes and tsunami, Onagawa Nuclear Power Station provided shelter and food for about 400 refugees from neighboring fishing villages for 3 months. As shown here in the map, this is where the Onagawa Station is. The roads that connect these villages with the downtown area of Onagawa were destroyed or heavily damaged by earthquake and tsunami. So people who lived near the power station had no place to go, and they came to our plant for shelter. They were grouped based on the villages they lived, and the leaders of the villages and our staff worked together to ease the pain as much as possible. For the first several days, food and water had to be brought in by our helicopters until we clear the debris from the road to the outside world. From March 11th until June 6th, we lived with about 400 local residents. This booth separation is something that we use when we do the table tennis, okay? So that ball will not go to the other players. So we use that barrier as a separation just for a little privacy. Okay. After the disaster, so much has changed. We were not flooded by tsunami, but instead we have been flooded by visitors every day. Okay. Thank you. Thank you for your vote. I'm not good yet. Okay, thank you. So many highly regarded professionals have visited Onagawa, and we are glad that we can share our experience with nuclear and non-nuclear communities. I would like to ask you to tell your colleagues or your friends what you heard today if you like our story. Earlier last month, IAEA sent a team of experts to Onagawa. And after 2 weeks of investigation, they concluded that structural elements of Onagawa were remarkably undamaged. So, conclusions. Let me make it clear that I'm not here to tell you that we were better than Fukushima Daiichi. I'm here to let you know that what made a difference and how you can prepare for the worst. We have shown that you can design your plant against a 13-meter tsunami. Onagawa is a proof, and Onagawa passed a real stress test. But I know we have to be humble, just like other nuclear engineers. That it is not just the 15-meter site blade that saved Onagawa. We have been upgrading our protection against earthquakes and tsunamis continuously, as shown here. In the 70s, we decided to install seawater pumps in a pit that from within the 50-meter site grade. Then in the 80s, we reinforced the site grade with concrete when we updated the tsunami protection. And more recently, we completed more than 6,000 seismic reinforcements inside the plants before the earthquake and tsunami. So we completed these seismic reinforcements based on the new analysis. So with regard to more safety upgrades, we Japanese utilities finally decided to install the filter containment venting system to all Japanese reactors. For Europeans, I know it sounds too little too late, but because you have installed the system almost 20 years ago after the Chernobyl accident, we currently plan to add more upgrades. Onagawa Nuclear Power Station survived a huge earthquake and tsunami, but restarting 3 units is another story, and it is as difficult as rebuilding tsunami-stricken communities, harbor facilities, and factories. As I said earlier, in Tohoku area, 340,000 people are still relocated. Tragically, Fukushima Daiichi of Tokyo Electric Power is located in our service area. People need stable power, but at the same time, their nuclear phobia is just too real and recent. Our restart effort, therefore, will nothing like we ever have experienced. We believe we need nuclear power in Japan, where 96% of primary energy source is imported. We must learn from this disaster and achieve even higher standards of safety for our nuclear plants. Thank you for your attention.
Thank you very much for this very interesting presentation. Okay, we have some time to entertain a few questions. So, did you raise your hand, or quickly to another person?
I can jump.
Okay.
Well, I just want to make a comment that this is because the Onagawa station being more safety conscious, listening to all the other estimates that were made, and they made a height of the station 15 meters instead of 5 meters. So I think those precautions really help. It's pre-planning, I think, which really is the most important thing to do, rather than waiting afterwards.
Thank you. I will tell your comment to my old boss. はい